In this video tutorial, you will learn how to display the latest satellite images of the sea ice cover from several satellite missions and how to interpret them. There are two satellite image layers available via the menu in the upper right corner. First, optical images provided by NASA's MODIS sensors, which are essentially photographs from space with a resolution of 250 meters per pixel and which are updated daily. The second type of satellite images is radar images provided by the European Sentinel-1 mission and the Canadian RadarSat Constellation mission. Radar images are the #1 tool to assess ice information due to two significant advantages. They penetrate clouds and are independent of daylight. Ice analysts obtain a lot of their knowledge about sea ice cover from radar images, which reveal structures within the ice cover invisible in optical images, such as ridges and deformation zones, and help distinguish between younger and older ice. You can download satellite images by right-clicking on the map screen. In the pop-up menu, you can choose between two different ways to download images, either directly for an individual tile or via the Get Multiple Tiles function. Options for a single tile download include a low-resolution radar image, which has an accuracy of 100 meters and a file size of about 38 kilobyte, suitable for limited bandwidth. Or a high-resolution radar image with full available resolution between 10 meters and 40 meters and a file size of about 3 megabyte, suitable for a larger bandwidth internet connection. You can also download a MODIS optical image with a file size of 20 to 80 kilobytes. If your internet bandwidth is sufficient, you can download multiple images with the Get Multiple Images option. Draw a polygon around an area of interest with left clicks, ending the polygon by clicking on the first starting point. Then choose your image product of interest, low-resolution or high-resolution radar images or optical images, in the pop-up menu. The total expected download size is displayed in the same pop-up window. Note that you cannot download more than 150 tiles at once this way. Unlike ice charts, which provide interpreted ice information, you need to interpret the satellite images yourself. Let's start with interpreting sample optical images, which is easier compared to radar images. Optical images depict what we would see with our own eyes from space. In many cases, clouds are visible. However, when cloud-free conditions prevail, optical images are excellent data sources for assessing current ice conditions. The main difficulty with optical images is distinguishing clouds from ice. Clouds are typically more blurry with less sharp edges, whereas ice often has large flow structures. Or snaky structures at the marginal ice zone depicting ocean eddy currents. Clouds can sometimes be transparent, with land, ocean, or ice shimmering through. If uncertain whether you see clouds or ice, compare the image with other data layers. If other information sources like sea ice concentration, radar images, or ice charts do not indicate sea ice in the vicinity of the location in question, you are probably looking at clouds. Optical images are not available during the polar winter. In this case, the image will simply be black. It's important to always be aware of the age of a satellite image, which you can display by clicking on the watch symbol next to the image layer name. If you zoom in sufficiently, you will see the age in hours and days. Let's continue learning about the interpretation of radar images. In contrast to optical images, radar images never show clouds. You always see surface features on land, ocean, or ice. The biggest challenge with radar images is that they look completely different from what we would see with our own eyes. The basic principle is, the rougher a surface, the whiter it appears on the radar image. In ice-covered regions, open water is usually smooth and appears black on the radar image, while ice often appears white. However, larger open water areas with significant sea state can also appear white. And summer ice with meltwater on top can be very smooth and appear black on radar images and bluish on optical images. For interpretation guidance, we have collected a set of examples in the explanation menu of the radar layer, including a table with typical grayscale ranges of different surface features. Generally, the structures and shapes you see on the radar image are often more helpful for interpretation than the pure radar backscatter value from black to white. If uncertain about what you see on a radar image, compare it with other information layers. If none of the other layers show ice close to the point in question, you are probably looking at open water. Similar to the optical layer, you can click on a watch symbol to display the age of the radar image tiles. A single radar satellite image covers only a few hundred kilometers, so in IcySea, you are looking at a mosaic of satellite images stacked like a pile of game cards, with the newest image always on top. This can make the age information look chaotic, but keeping the game cards example in mind makes it clear why certain regions are older than others. The different age of the information may lead to the situation that you see the same ice structure on two images at two different locations. When you compare the two recording times, you can even assess the ice drift distance and direction between the two satellite recordings. You may have noticed that the tile structure is evident in the grayscale shade of the image tiles. This effect arises from scaling the maximum radar backscatter value to white, individually within each tile. Although this makes the map appear more blocky, it is a deliberate design choice. Without this feature, certain details would not be distinguishable and would either appear entirely white or black. In the next video, we will proceed to the remaining information layers: sea ice concentration, sea surface temperature, and ice drift forecasts.